We live?
We're live.
We are live. Hi, everyone. All right, 7 o'clock. Let's get the show on the road. We need Brian back. Sorry. So, so I am Bob Tremblay. I am the president. This is the Warren Astronomical Society. Welcome, everyone. Do we have any first timers? You're not a first time. You're just a returning. Okay. No first timers. All right. So let's roll call again. I'm Bob Tremblay, president. Let's. Jeff, oh, all right. You crash a lot of parties, don't you? All right. Yes, I'm here. All right. So we are live and virtual. We are at Macomb Community College South. So you can join or renew your membership online apparently, since David is right there on the screen. So yeah, I know David Wave. Hi, okay. So we have some more. We have David. Do we have any calendars left? Are they all
We
going?
do have a couple of calendars left in my briefcase.
Okay, so obviously you're not going to get those here. So Cranbrook possibly. We have a couple, although it's a little bit late in the year. I still need to get one myself. Wasp wearables are available from Mark Kedzier. You can see what's available in our newsletter. Mark is here tonight. I got to get with you and get some of those things. All right, astronomy at the beach is changing venues for this year. Island Lake State Park is under construction, so we've had to find a new venue, and we're going to be at Mayberry State Park, which is west of Northville, so it'll be a little closer. But the skies will be a little more light polluted, so we're thinking about. I made the suggestion of having some folks with the EAA telescopes, show up there. Since a lot of people are getting those now, so we're talking about that. So again, Mayberry State Park, west of Northville. I'm going to be changing the website to be more information, and we had almost a complete changeover of the GLAC board. GLAC is the Great Lakes Association of Astronomy Clubs. They host astronomy at the beach, and our Brian Odom is no longer doing publicity. So we have a lady who just took over that position on Monday. So yay, but she's going to need help. So we're reaching out to all the members of the clubs. If you can just when we have flyers and stuff, if you can get it to people, libraries, anybody who might be interested, teachers. We want to spread the word. Anyway, GLAC meetings, if you're interested in helping with astronomy at the beach, GLAC meetings are held the second Monday of the month via Zoom. um Interesting announcement. Beaver Island State Wildlife Research Area has been certified as Michigan's first international dark sky sanctuary. So I think we should go talk to them and do something with them. That would be cool to have an event up there. Um, Marty Kuntz is still in the hospital and receiving guests. I think I'm going to go see him tomorrow. I'll try to. Officers reports. My wife and I, and my daughter and my granddaughter went and saw the eclipse at the National Museum of the U.S. Air Force in Dayton. It was my first total solar. It was awesome. We were set up in the museum under the wing of a B-52. I actually didn't know that. When we were setting up, I saw these giant engines. I thought these engines were just hanging from the ceiling, and until I walked way across and looked back and oh my God, we're under the wing. It was huge. So Connie had a continuous line for hours, and it fed over to me. And I talked to people. We actually had at least one WASP member show up saying, I didn't know you were going to be here. And one guy from Taylor said, I didn't know there were astronomy clubs in Michigan. So yay. Yay. So, the lady who was the special events manager at that location would love to have us back, or anyone on the club. So they would love to do workshops and have people talk. So I can get you in contact with her. It's a great place. They have, if you're a Kerbal Space Program fan, they have smallish rockets, but they do have rockets, and they got planes galore. I didn't even get to see all of them.
You got a gym.
It's an amazing place. Yeah, yeah, Wright-Patterson Air Force Base. Yep. They gave us. We were the only ones inside, and we were there, and we packed up at 2, went out and saw the eclipse. So, statewide astronomy night at Belle Isle, I was set up at the same table with these things. And I didn't have any handout material at all because I gave it all away. We took four of these giant JPL boxes and 500 solar glasses. I didn't come back with any of it, not one bit. Yay.
We need to print more.
We need to print more.
We have flyers. We have trifolds. They're right there.
Yeah, and there's like five left.
Printed
Yes, we need.
to see how they turned out. But if you want to grab some,
Yes, we need more. You're right. We do. Okay.
that's not for 20 years. We'll have a different flyer by then.
Yeah, well, a new board by then, hopefully. So, an interesting article I'm writing for the VO right now. King's Cross in London, if you're familiar at all with Harry Potter, they're having an outdoor exhibition of Where I Work, an award-winning photography feature from the journal Nature. The exhibition celebrates the many roles and types of research done by scientists globally and challenging the stereotypes of what scientists look like. Spread out all around King's Cross on what are called photo benches are images of scientists doing science. And one of them is this fantastic picture of Brother Guy, which I'll show you later. It's amazing, but so that's pretty cool. Each one of the scientists, it says what field of science he's working on, a short, like real short bio, and a link to a story on the journal Nature. So that's pretty cool. I'll be including a link to that article when I publish it in probably in the next newsletter. So Dale, are you online? Want to give you our first VP report? Got to unmute. Can't hear you. No, not good. Can't hear you.
Yeah.
There we go.
Can you hear me now?
You're good.
Okay. Wow. It's a repeat of what I always say. I need speakers, you guys. Unless you want to hear a lot of boring me, come on. You can do it. Sorry I couldn't be with you guys in person. I have COVID. But glad to be able to connect this way. Cheerio.
All right. Riyadh is our observatory chair. He is on the road. He says we had a few scouts at Stargate this Saturday, and our next open house will be April 27th at 8 p.m. Treasurer David, what's the good news?
Hey, we got bucks.
Yay!
Our checking account, we've got just over 26 grand in there. Our PayPal account just went over a grand. So any sort of projects that the club wants to do that involves finance, I got a card, I'll write a check. We do have some bills coming up since our credit card's been busy the last month since we got it. So we do have some bills coming up next month that'll have to be paid on that. But other than that, we got bucks.
Cool. Thanks. All right, Secretary Charlie. Charlie, oh, he's over there. There he is.
Yeah.
Hi.
Well, just to mention, I went to see the total eclipse. This is my first time, and perhaps my last time.
Can't hear.
Great.
Charlie, can you come here?
Yep.
So our viewing audience can see you.
I'll give you my point ahead of time. My point is, if you're ever thinking in the future of going, just go. We didn't have a plan. We knew it was south. We knew where the swath of totality was, but we went on this wild ride, if you will, following the Google line. We were between all kinds of farmlands and just creeping our way through southern Michigan and across and into Ohio. And there'd be a line of people behind us, just like ants on a path, between these farmlands. And like, no, follow the blue light, because it'd be big backup to traffic. My girlfriend, no, follow the blue line, because We do not want to get turned around out here. We won't make it. So we followed the blue line. It got us around all the traffic. We got into Ohio, maybe 10 minutes or so. It got to be 2:55. We went the next exit. We're like, it's time. We took the next exit, maybe not even. There were people in front of a restaurant or a bank. We just pulled in that bank, sat down on the benches there, and there it was. So that's my quick story about that. As far as being the secretary, um, I'm continuing to work on the notes and to get it ready for the newsletter here. And that's the big report on that. All right, thank you.
You reminded me, when we were going down to the Eclipse, we stopped off at one of those rest stop areas, and there was practically no place to park because people were sleeping in their cars waiting the Eclipse in this rest stop. It was hilarious. And when we were at this museum in Dayton, I have never in my life seen so many porta potties. There, oh, there were 30 over there and 30 over there and 30 over there. They were everywhere. It was amazing. So, outreach, Jeff. Next.
Yeah. So Bob covered some of it, the stuff at Stargate. Not here. Okay. Bob Berta, there he is. He did an interview with Channel 7 that was pretty cool. Bob Tremblay it was in, what was it, the pre-press?
Yeah.
So that was pretty cool. Kedzier and I were not at the table. We had scopes out on the walkway at Belle Isle this past weekend. That was a lot of fun. Oh yeah, I know. We were all pretty busy. Nobody really spoke to anybody. We had a continuous path of people pretty much the entire time the event was. So that was pretty good. Mark Kedzier was at Grosse Pointe on the 3rd. Yep. Ken and Dale were at Cranbrook during the eclipse. Sorry, but Ken got on the news.
How many people got into the news?
Just him and Bob. Let's see here. Oh, okay. So I have to put a report together for the Wasp. So if you guys have eclipse stories, please send them to me. It's technically outreach, right? So as long as you mention that you're a part of the club uh, and you had a good time, send it to me, and I'll get it put in there. The other thing, the 27th. Discovery Learning Center, I might have a volunteer. Okay. But there's more of those. There's one every month. So if you would like to participate, it's a pretty low-key event. And hopefully we're gonna grow it into something a little bit more. Yeah, you should. You don't do enough. The other thing is your outreach coordinator. I just want to float the idea. How many people did hit traffic during the eclipse? Back. So, as the scientific community, should we be gatekeeping these? Should we have scaremongered people to stay in their homes so that we could enjoy the roads? Oh no, yeah, you should stay home. I had a coworker of mine who told me he didn't know that he could look at the total solar eclipse without glasses. So he said, I didn't really see as much because I thought we could only glance at it. And Jeff, I'm going to be real honest with you. I thought I was burning my eyes and I stared at it for 30 seconds anyway. That is the power of a total solar eclipse. This man thought that he was doing retinal damage. It was like, I'm taking it. There's no way I'm taking my eyes off this thing. So we might be overly cautious about people staring at the sun. There was way too many news people, right, that aren't us, that don't know, that just said, don't look at it. I actually saw YouTubers that are famous scientific communicators that have way more followers than any of us here combined. They got it wrong. Hey, make sure you got these glasses to look at the total solar eclipse. All right, this is my own cross to bear.
You say right on them.
If you can remember in 20 years, uh, uh, it's also been extremely frustrating to me to hear late night guys and people on the news that were not at the path of totality. And maybe you experienced this as well, because I had a lot of people that I said, go, go, go. And they said, eh. And then when I get back and I say, it was great, they say, yeah, we were here. I don't really get it. I'm like, yeah, because you weren't there. Of course you don't get it. And so I'm hearing people on the news, yeah, we went out and we looked through the glasses. What is all the hubbubaloo? It's like going to a football game or a concert, staying in the parking lot and being like, I don't think it was really that good of a show. So anyway, the last thing I have, where's the camera? It's here. I am giving the main presentation at the next Cranbrook meeting. I'm actually working on it right now. I think it's going to be pretty good. It's about Apollo. If you're a fan like me, check it out. Yeah, I think it's some of that best one. All right.
Hey, Jeff,
Let me know.
I would just like to give credit. I spent Eclipse Day at Cranbrook, but I also had Ken and Lori Heilich, Tina Long, and Robert Bolton with me. Okay, just like to acknowledge their help.
Are any of them here besides Ken? Oh, all right, we got a couple of them.
Thank you. Make us look really good for Cranbrook. Thank you. And just so all the I took the advice of all of the eclipse talks I've ever heard, and I did not when the eclipse started, I did not take my camera out, and I watched it the entire time. I took the glasses off at the right time, and yeah. My daughter, on the other hand, got great pictures, and I am a little jealous, but only a little jealous.
That prominence is.
Oh, you can see that with your bare eyes. I was shocked. That was very cool. Bob, you got stuff to share? We're almost there. We're almost there. Publications. Talia is not online here, so the loss is up. So we'll go with that. So if you guys need to contact the board for any reason, board@warrenastro.org. So astronomy in the news, we have 5,612 confirmed exoplanets, up from 5,599 at Cranbrook, and 7,138 candidates, up from 7,114 at Cranbrook. So it just keeps going up all the time. Interesting bit of news. Who here knows Mikhail Baryshnikov and Rudolf Nureyev? They both got asteroids named after them. Yeah, so the latest IAU bulletin on the working group on nomenclature for small bodies. I'm looking through it, and those names jumped out at me, so I did a post on them. So is David Levy here? No, David Levy is not here. So great. Huh?
He's in me.
Oh, well, that's why he's not here. Okay. So I am going to see if I can share this image here. This is the sun right now. This is from spaceweather.com. Let's see, where is it? Share that screen. There we go. So you guys seeing the sun there? Yeah. No, that's Jerry's thing. Okay, great. Of course it is. There we go. So that is the sun from spaceweather.com today. So we got a whole lot of sunspots, and like I keep saying, my phone I get alerts like crazy. My both my wife and I now, it's hilarious. We get them at the same time, so our phone goes, we look at them, flare. Yep. Yeah. In unison. Yes. Yeah.
Almost in the center of the sun. So
Yeah, it was 6 o'clock. It was 6. It was very cool. It was easily visible. with the naked eye. I was shocked.
The one we were with, we were on a family farm. These people had like 7 kids from like 7 to 20 something. And one of the kids shouts out, "It's like a red LED." And I thought, that's perfect.
You know,
That's exactly what it looked like.
it was bright and it was sitting at the bottom. Yeah, it was cool. So Riyadh,
Very
still
right.
there? Okay, right, Riyadh's on the road, so he's not there. So we're not doing any Stargate stuff. So we have any any astronomy questions? Yes.
Diamond ring only appear in the after. Not around the 3 times.
Actually, it does. It appears for a moment. It's the last instant before the sun disappears. I actually saw it at this time before it disappears and when it reappears.
I think people risk the beginning like this.
Yeah, yeah.
I didn't take my glass off.
I took
It
the
was-
class- I took
it-
the class off too soon, right?
Yeah, so did I. Yeah,
Fantastic.
yeah. So it's easier to see the second one.
Well, your eyes are also more acclimated to being a little darker,
Yeah,
unless you have glasses like darkening goggles.
right, yeah.
So, any observing reports? Yeah, eclipse. Because Dale, you want to show that time lapse?
Okay.
You want to come up here and talk about it?
I took this with my C Star, and the settings are one single frame every 5 seconds, which gave me an opportunity during the moment of totality to rip that sun filter off. So you get to see a little bit of a diamond ring here. The Cotter, right by Fort Wayne, Indiana. And part of the reason I went there was I was trying to use the National Weather Service, the atmospheric app, and my weather bug. And I'm a little miffed at our National Weather Service because they promised us a noon update, which gave me 2 hours to reposition in case there was cloud cover. They never did the noon update.
It's cool.
So using atmospheric, it was pointing me towards the Cotter more than Napoleon, so I kept shifting that way. And it did work out pretty well. I noticed as the eclipse started, definite haze started to appear. And I was actually worried about cloud formation, but I didn't actually get any clouds.
Anybody? I saw shadow bands after the second diamond ring. Anybody else see them? They were on the cement. It looked like waves on the cement. It was bizarre. I pointed it out to my wife and my granddaughter. I said,
Those shadows can kill. So
yeah, look, that's not quick.
we didn't experience any nature stuff, but friends of ours
Very cool.
said that the birds definitely quieted down. Another friend of ours said that they saw bats.
Really?
And another
Bats.
group reported that birds were dive bombing people.
Oh, where I was, I noticed that the birds were singing the entire time.
Really?
Yeah.
It depends on what kind of bird, because if they're birds that sing during the twilight hours, they'll usually pick up. But yeah,
I was enjoying it instead of putting in my earbuds.
Born and raised up in the tough part of the and I experienced all my younger life. But there's a guy up there now that I went to school with. He's real big into birding and all of that stuff. And he's a geezer too, like me. But anyhow, he ends up being a deal of where he was out doing some photography stuff, and he saw this group of turkey buzzards. And when it started getting darker and darker, they landed in a tree, and they were ready to roost there for the night.
The same exact thing happened in Texas. There were about 20 black vultures in the northern campground we were at.
we saw one dead tree, and there was like 6 of them roosting during
That's
it.
cool.
So
We got
real close to this car, and maybe they're pretty skittish.
members of the audience are talking about birds roosting in the trees during the eclipse.
And one was in the news. I thought this was totally strange. Like you talk about the media, like do not wear your solar glasses while you're driving. Somebody needs to read that for real, but they published that. And where we were, there's a hill coming down where we were, and people were literally on the road stopping to look up, and you could hear the semi trucks locking it up.
Just like all the signs saying don't do that. We pulled off to get something to eat in some town. I don't even remember, in Ohio, and there's like eclipse viewing party this way, eclipse viewing party this way. So yeah, they were just everywhere.
We got so far.
So any other observing reports or more eclipse stories?
Thing that I wish I could have.
I'm gonna come up here and say it. Our audience, come on up.
It was a lot of fun. That's all it was just
I'm so glad I went.
I've seen 13 of them, and this particular one was in the top 3 without question. And the crystal skies were amazing. It was quite something.
Where did you see it from? Like Texas, was it?
I was with Bob. We were at what is it? Batesville. Batesville, Arkansas. We kind of made a decision of that. It's right on the center line, and we landed on the tarmac. I don't know how much Bob told you, but we landed on the tarmac. There were all kinds of other people coming over there also, and we took all the equipment out and put it on the tarmac right next to the jet. And and it was cool. It really was. It was one of the best I've seen. It really was. That it was amazing how the clouds were there a little bit in the very, very, very early time when we got there. But by the time the eclipse started, it was crystal from horizon to horizon. And everybody had their solar glasses. I had a pair of solar binoculars, which are kind of cool. And Bob had his hydrogen alpha on his telescope. And I had my little telescope with me too. And the people that were with us, just Bob and Brian and I, had seen eclipses prior to that. I guess maybe the pilots saw it when they last year, but everybody else had never seen an eclipse, a total solar eclipse before. And the entire airport was like, they were just like freaking out. That's how amazing it was. And there was a wonderful prominence. Did you show them the prominence, Bob, that one at the bottom?
Yeah, I haven't shown it to them yet. I don't know whether they've got it keyed up, or I can show it from mine later on when I'm doing sharing.
The one of the prominences on the bottom, I'm explaining to the people that it was half the size of Jupiter. It was 30,000 miles across. I mean, it was about half the size of Jupiter, and they just the gasness of how big the sun was compared to Jupiter was like they were just saying that can't be it. That's that. And I said, and our sun is one of the smallest stars, you know. So you go figure. It was quite an event, and we really had a great time. It was the best. Oh.
Okay. Well, okay. One of the things that I observed, this is my second total solar eclipse. So that was a real thrill for me. But we were down in Kentucky, Paducah, Kentucky, and we pulled over we couldn't go any further. We pulled over into the Walmart parking lot with 1,000 other people there. But the thing that really stuck out to me when that total eclipse happened, I wish I had a recording of it. The crickets
started going. Yes. Yes.
It was stunning. It's amazing. And then all the street lights came on too, by the way. But the effect on nature, this eclipse is really amazing.
We saw some of the birds fly to roost, you know.
Yeah. The other thing I noticed was, when you have a normal sundown, it's dark over there, light over there. It was sundown all the way around. I turned around and it was a uniform dusk. And so anyway, I just wanted to make that observation. It was very
Yeah, it was very strange when we were watching it. People were cheering right before totality. I'm like, why are you cheering now? And I actually said that. And then totality happened, and it was like, and everybody was caught. I wasn't expecting that.
When's the next one?
2044, and oh my goodness, the path is really inconvenient. It's like west of North Dakota up into Canada and Arctic Circle, but Jeff tells me that in 2045 there's another one that's almost a repeat of this one. 17. So
Want to know the last of them.
so
The
well,
next,
I-
the next total solar eclipse goes across Europe. Okay, in
that's
August the
right,
2nd,
right. That's 2026.
26th. Yeah.
And that one, if you take a look at that, the eclipse path for 26, the path of totality goes right past this little peninsula in Iceland, sticking out into the Atlantic.
Right.
And I'm like, that's going to be packed with people.
Yeah. It was
But
amazing.
from what I heard, that one, the sun's going to be low on the horizon all the way along, so you're going to be able to get those really cool eclipse on the horizon shots.
Cool.
All right. So any other eclipse stories? Since they seem to be all eclipse stories.
I've got some eclipse story. Um, you know, as you know, Ken and I and my son Brian went down to Arkansas. The trip down there was interesting because we were checking through astospherics before and then on the way down there, seeing where the best spot to go was. So originally we had planned to going to Texas. So as you know, Texas was not the place to go. It got rained out or clouded out, so it was pretty bad. So we looked between Missouri and Arkansas, and we found a place right dead center, not too far from Little Rock, Arkansas. So that's where we went. The town is 10,000 people live there, so it's a small city. The airport was just big enough because the airport runway was, you have to have at least 5,000 foot for a jet to land, and we were in a 9-passenger jet, and that was really a cool trip. The neat thing about that was we got on the jet. We took off when, Ken, about 8:30 in the morning.
Right.
Got there quickly, set up, observed, took pictures and everything else. Got back in the jet and flew home, and I was back in my house by about 7:15 at night. No traffic. Ken and I, and some of you who went to the 2017 can remember the horrid traffic jams we had to fight through. So for that one, so it was worth it just to avoid that. One thing I would say early on, I forget who was, whether it was our David or somebody was mentioning about all the outhouses they found where they were. They couldn't outdo us because where we were, we had the most expensive outhouse in the world, a jet.
Hey, by the way, there was one other thing I did want to mention. This is an astronomy thing for each of you. You know that all eclipses are in what is known as a series, about 75 or so. They happen 18 years and 11 days after the last one, 1/3 around the Earth. So Ceres 139 was with this one. And I saw the one, it's the same shape of the eclipse is the same shape when you look at the path. I saw the one in 2006 in Libya, just before Gaddafi was overthrown. And it was the same shape, but it went right through Africa and right through Libya and up like it did in the United States, right through like that. So there you go. That was an interesting thing. Ceros, that's what it's called.
Boy, Ken, you should do a short lecture about that. I'm sure Dale would love that.
Anytime you want. I've got one written up. So if you ever want to do it, I'll be glad to do it. Sure.
Go after him, Dale. Go get him.
Don't worry about it. Dale knows. Dale.
The sort of the next country that gets sort of a number of them, good ones, in relatively short succession. It's I think we're going to get 3 of them within a.
Southern skies are something I'd like to see. 2028 in Australia for next
Australia, right?
eclipse.
Well, I think
Never seen southern skies. It's next.
Yeah, well.
Back through Sydney. So
Yeah.
Maybe you can speak to this. My intuition tells me like my wife really wants to go to Iceland to see Iceland, and I want to go to see the eclipse. But the assumption that I'm making is it'll be the worst time to be in Iceland for
No, you're
anything.
gonna, it'll be in August. It's not that bad. It's really, you can go to Greenland as well. But the point is that just to give you a history, I went to see one at the Faroe Islands that's north of England and between England and Iceland, and we got clouded out. So it was nice that it got nice and dark, but you couldn't see the eclipse. So I would be very, very hesitant to go see one too far north or too far south. I really would. Now, Fred Aspanak has been to two in Antarctica. So, this is, so there's, you could get lucky is what it is. It's the
Last
season.
field trip,
Oh,
Antarctica.
yeah.
There you go.
I remember after the 17th, we went into Yellowstone, and it was the absolute worst time to go to Yellowstone
Okay.
because everyone was there.
Oh, that's the other thing that you have to watch out for. But if you go with a group or something like that, it was, I looked at it this way. I couldn't get away from my wife for too long. And I've gone to all these eclipses, and all of my eclipses that I go to the other places in the world. And that trip cost you $3 to $4 grand, absolutely minimum. This trip that we took was $3,000 to pay for the fuel each. And it's one day, but you're down and you're back. But if you go on a trip, you go with Gary Spears or some of those other really, really good trips that you see, you'll be out there and you'll see other countries, and that's very nice. The eclipse is only 4 hours long or something like that, and that's the point is that you can see a lot of nice places in the world, but prepare to pay for it. That's what you're talking about. That's it.
Any other eclipse stories? All right, so why don't we take our yes, like what here? Okay.
It was kind of cool. We're all a whole big group out in the park and stuff like that. And as it's getting closer, all the people were, here it comes, I'm so excited. And then the eclipse and everybody's, oh my gosh, that actually added to the excitement. Don't you think? Yeah.
Oh yeah.
Response and stuff, that really added to the
Yeah, there was like 20,000 people outside at the museum I was at. It was just absolutely packed.
I had told some people that I was going to make a spear so that we would have some sort of weaponry to scare the moon into cleaning up the sun. And then I thought, I don't want the moon to cough up the sun. I want it to stay in totality and freeze to death. So I didn't make the spear, but the moon coughed up the sun anyway.
Oh. All right, so why don't we take our snack break and we will reconvene, let's say straight up 8 o'clock. That's 20 minutes. All right, so take a break, take a bio break, go get a munchie, go get a drink, and we will reconvene at 8 p.m. Stopping the video.
Can I bring up a phrase that I'm looking for hearing? Ian, can you hear me still?
Yes. Yeah,
Oh.
absolutely.
Oh, okay. How is the wife doing?
She's doing okay. She had chemo yesterday for her liver. She has that's a 2 hour chemo treatment that she has for 2 hours, and then 3 weeks later they do it again for 2 hours, and then 3 weeks later they do it again for 3 hours. So for 2 hours, and she seems to be feeling a lot better, which is really good. And we're fighting it. It's tough. but but she's a tough kid. We'll
Yep.
see. We're just looking to make sure that we can do whatever we can do to treat her right. And I did the right thing with this trip, but there was no question about it. It
Yep.
was, so
That's good.
anyway, it's been a it's been a tough row, but she'll get through it.
Yep.
We'll see. We'll keep our fingers crossed too. So
Yeah, my wife has the best fan in Texas. Her husband's going through the same thing.
really,
So,
no kidding.
yeah.
Lung cancer, lung to start.
Pardon? I didn't catch that.
Did it start at light lung or where was it?
I think it's his lung, but I'm not certain.
That's the one that really has a problem because that small cell crap.
Right, right.
And those little cells, they penetrate through the veins and through the arteries. They go through the pores. They're very, very
Right,
tight.
right.
And then they travel. She had 2 weeks of radiation on the brain because there were a couple of lesions. And we just have to pay attention to what the doctor says, keep her oxygenated, and
Oh yeah,
follow their rules, and maybe we'll get a
Yep.
break. So we'll see. It's
Yep.
it's something else. It really is. But you got to fight it. That's
Yep.
what it. I was trying to see if I could load up those pictures, some of those pictures, but I'm not not very successful at it.
Yeah, I don't know whether I can share stuff on here with people yet or not. It's got the thing to share screen. I don't know if I can show mine on here or not. I don't know if they've got it turned on back in the meeting where they can see them there or not. Let me see if I can do it here.
You share it.
Yeah, I hit share, and then
I think there's a thing up there that says share screen. Did you see that?
yeah, I got that.
Well, I don't know. Well, let me see something here.
We can see it here. Let me see if
Yeah,
I
yeah.
can.
There you go. There you are. That's it. You got it.
There you can see there's
Yeah, you got it.
a one picture there. You got that?
We'll load it. There we
Yeah,
are.
the
Oh,
plane. Got the
you
plane.
got to show that to everybody. That's really
Yeah.
dynamite. Yeah. It was something.
That was, you got a lot of people don't, the thing with the different cloths and everything, maybe you could explain that.
Oh, I
Different
will. I'll be
colors.
glad to.
A lot of
Sure.
people didn't pay attention to that. And I've also got that one picture, I think, of the, so I can go back here. I can go back, dumping me. If I have it on here, but that picture where I got the one with the multiple eclipses.
This one here, over here at the top right. It's behind the next one over, two over. This
Two
one
over here.
One more.
Yeah.
Here.
See if I can I got this picture thing in my way. Let me see if I can move it a little bit. There we go. Okay. That one.
That's the one.
Yeah, with all the multiple eclipses.
That's cool.
Yeah.
That is really cool.
I wish I had brought, these a metal colander. Those are the ones that are cool because we have a metal colander, besides having the multiple eclipses, the fact that it's curved like that, you get all sort of fancy, dramatic shapes and everything with the stars. Kind of cool.
Fabulous. Yeah, I would just keep it up there, and when they come back, you can show.
They come back with you.
The one you want to show them is show them RK 8129. That's the one with the little prominence. You got to come down here.
Yeah, right there. That one there.
That's the one you want to show them.
That's what shows the
that'll
prominence
blow
there.
them
Yeah.
away, that little
Oh yeah.
prominence at the bottom.
Oh yeah. And also this one shows it too. The one with the this one.
Oh yeah. Well, that's close up, but I'm saying that yeah.
Yep.
And that's the one that's over there at the on the corner on the left side. That's the one that's half the size of Jupiter.
Yep. Well, at least maybe even bigger than that, I think, because you get what 99 Jupiters across across the width of the sun.
Yeah, but it is only no, it's not 99. It's no. The sun is 864,000 miles across. Jupiter is 86,000.
Oh,
so
okay.
10. So
10.
that one is about half the size. It's 36,000 miles tall. That's what it is.
Oh, okay.
And this one over here is a little taller, but not quite as solid as that one is.
Yeah, these little ones over here. Yep.
When he comes back, we let him know that
we'll show him. Yeah.
show them these pictures. That's fabulous.
Yep.
That's that's great. Yeah.
Let me see if I can stop sharing it here. If I can get back in here and
Right at the bottom, isn't it?
yeah, I think it is down here. It's
Oh, look at that! I like that. That's your Alfa Romeo, huh?
yeah, yeah, I didn't want that. I want to go back to
You just quit the screen.
I gotta find the right here, the Zoom meeting one. There we go. I think that's one of this thing. This thing always gets in the way here.
Well, there's a thing at the thing that says share screen at the bottom, and then at the
Right, yeah.
And
I gotta turn that off though.
And
Or
share.
get a new share. Yeah.
That's what you do.
Let's see here. That it?
It says at the top. I think there's one thing at the top that
Yeah,
is
usually at the top. Yeah, usually at the top. I
it's,
got things are all over the place here.
end screen or something. There it is. There's something up there. It says end share or something. View options.
Yeah, usually there's an end share. Stop video. No, that's not it. There's a new share. I don't want the new share.
Put your thing at the arrow at the top of the screen, and something will pop down.
Yeah, usually it does, but it's not doing it for some reason.
I don't
So
know.
I can find what's going on here. Maybe there. Okay, I see something here. Let me see if I can try something here. There it is. Stop share. There we go.
Okay,
There we go.
You did it. So let's tell them that you're going to do that. That's
yeah.
a great thing. I have a picture here. I wonder if I could show you this one. It's gonna be okay. I wanted to find this other picture that I have. Let me do this. I'm gonna try something weird. Window. There was a picture, a multi-picture that was done. Let's see if I can grab it. It's down in here. Hold on a second. Somebody took this absolutely wonderful picture. See if I can find it. See if I can load it. Come on. There it is. This is a terrific picture by a fellow named Peter Harlech. And he caught the let's see where okay. He caught this comet.
Dale, I've been instructed to tell you that we need to order more business cards. Select more rifles as well.
Let me see if I can get down here and if I could show this. That ain't it. I wanted to see. I don't see it. Maybe that one. Maybe that one. Nope. It's not showing. Nope. I just won't do it. I can't get there. It's not letting me there. Okay. I tried. I've got a terrific picture here that really gets the idea across. Let me try something else here. No, not going to show it. Nope, won't do it. I can't do it. I can't get there. I got this terrific shot. You know what I could do? You know, I'm smarter than that. Just a second. I just had an idea. I just had a good idea. Okay. Let's do this. Here's a picture. See, maybe we can get it.
Yeah, it's not picking it up.
It might.
Yeah. I see what you're doing with the thing, but when you put the thing up front, then it just blanks it out and it just shows your background.
Um,
Hmm.
Well, I could kill the background is what I could do. Close original background. How about that shot behind us? Here's one there. How about that? Let me get out of the way. Kind of gives you an idea. This guy caught this picture of let's see if I can add a picture. That's what I'm talking about. If I took this one and put it here. Add one. Add an image. This one here. Open. Okay, let's see if I can do it here. There it is. Let me get out of the way. Do you see this is the same eclipse, but there's a comet on the right side of the eclipse. You see it? Comet on the very left side, your left-hand side. Bob, can you hear me?
Did you see the comet when we were in Arkansas?
No, I did not see it, but a
Yeah,
friend.
I didn't really even look for it. I forgot to look for it, but some people said they did see it, in other locations.
But look at this wonderful composite that this fellow made.
Hmm.
Thought they may get a kick out of that one.
Yeah.
Okay. Okay. Anyway, so what we can do is when they come back, we can show them that. There we go. How do you like that? There's the comment on the right side of the screen. There it is right there. Right up there. And that's about the right distance too. Very cool.
Thing I liked was how when it was getting dark, you could see 360 degrees. It was like a lampshade coming down all the way around you, like a curtain coming down. That was cool.
Mm-hmm. Yep. It was it really surprised me how the skies cleared so magnificently. It just went they just went clear.
Yep.
You know, and Parton and Lenny Son and Dick and Steve Buden haven't let me alone since.
I've been getting a lot of emails back and forth from them also. That was so cool. And Banda asked me if I wore out my first pen for autographs, and I said I had run out and buy a whole box of the Pentel pens, and I said I'm almost out of them.
It was something. I don't know what I'm going to do with all the solar glasses, but
Yeah. Well, they can always sell them at a discount rate for the eclipse next year, right? Don't tell me you got to go to Spain or Greenland to see it, but
listen, that's it. I think there's a partial before that, isn't there? Don't we have a partial coming?
maybe a partial. But I know the full solar eclipse is supposed to be the one that's going to be in with the
Spain.
Greenland and
Yeah, it's going to go
Spain.
right through Spain,
Yeah,
and what you want to do is you want to go to Barcelona.
yeah.
So you get it late in the afternoon, and it really is cool.
Mm-hmm.
That's cool.
Yep.
And then of course I guess the one after that is Australia.
Yeah, there's an Australian one. There is one that's going to be across all of Europe too, isn't there? I think.
That's the one that goes through Spain, goes through everything else in Europe.
Yeah. 5-minute warning.
Oh, okay.
Get your bio break in.
See, Bob, see this picture behind me?
See the picture, Bob Tremblay? Oh, he may not be on. Yeah, Tremblay doesn't see it because he's got his sound turned off.
If you see the picture, any of you that come back, see the picture. That's a picture of that eclipse done with layered, and on the top right of the picture, there's a comet.
Actually, top left on this one.
Top left. So. And I just took a picture of my pocket. I just took a picture. I sat down and it took a picture of my pocket.
I'm thinking what I might do is might do a write-up, an article for the newsletter, talking about sort of our adventures with the plane and things we did and everything else there. One thing I've been telling a couple of people, the story about the guy who there was I guess our driver would transfer us back and forth from the plane to the little mini airport there. And the guy asked, "Where you all from?" And I said, "We're all from Michigan." He said, "I couldn't tell. You all speak Yankee."
Y'all speak Yankee. That would be our.
Yeah, that was funny.
Speak Yankee. Yeah. It was something else, I'll tell you. I'm trying to figure out why my computer isn't moving over the pictures I added to my thing, but it didn't. I don't know why. It says no items. Well, maybe
By the way, I sent those pictures and I sent the story to Matt, the guy, the guy that's the manager of the Webb Space Telescope, cameras. They either talk for our club. And he sent some of his pictures to me, and he said mine aren't anywhere as good as yours, but he had some that were decent, pretty nice, But he said, "Man, you guys had the Cadillac trip," and he talked to some of his buddies that are pilots and said, "Man, that's going to first class," So,
it really was. It really was amazing.
Yep.
It just was. It was amazing.
Well, evidently, I guess I-75, it was a traffic, jungle.
That's what I heard.
That I heard.
Yeah. A lot of people said that it was really very, very hard to It took for hours. It
Mhm,
wasn't so
mhm.
much going. Everybody were thought to go early, but then they didn't realize you got to do it when you come home.
Yep, yep, yep.
Change everything.
Oh, yeah.
Well, what did we have? What did we go? 30 miles in 3 hours or something like that?
50 miles between Douglas and Casper is 50
Yeah,
miles. Took us 5 hours.
5 hours to get across. That's right.
Yeah. And that evidently was that way all over the place too. They said going like
It-
back then, people going up to Chicago, that area when we were there, it was a horrendous nightmare up in that area.
But this one blew away the one we saw there. It really was.
Oh yeah, this is much better than well, I won't say much better, but the Casper was cool too. But the this one definitely was a better one.
Is Bob back? I
I
don't
think
know.
he's test driving getting his video set up. We may not be able to get our stuff in till maybe at the end of the meeting or something for the additional stuff.
Why not?
Yeah, I was thinking we could actually write it up on the upcoming the one at the
Monday one.
Cranbrook. We could do it there and go there and show the pictures there or whatever.
We could put it together. You and I will use some of
Yeah.
the ones that I got from Fred Espinac and such.
Oh yeah. But it'd be good to get some of the stories, like that one about the different colors of clothes. That's a lot of people didn't have a clue about what that guy was doing. So that's a good idea.
All right, you ready, Jerry? All right, we're gonna get this. No, okay.
Bob,
All right. All right, so let's get this show on the road.
Bob, take a look at my over my shoulder.
Yeah. If you are just joining us, this is the Warren Astronomical Society, and we're just about to start our feature presentation tonight. Our guest is Jerry Dunifer. He's a professor emeritus at Wayne State University. He's a member of the faculty in the Department of Physics and Astronomy for 35 years before retirement. While active in the department, he served as professor and associate chair of the department for several years. His research program there involved the study of the electrical and magnetic properties of high purity metals at the temperature of 1 Kelvin. He also played an active role in the astronomy programs at the department, including the Wayne State University Planetarium and telescopic observing facilities. Since retirement, one of Jerry's hobbies has been visiting a number of major and historic astronomy observatories around the world. He's visited dozens of different sites and has traveled as far as the geographic South Pole and geographic North Pole and many places in between. His topic tonight is viewing the universe from the South Pole. Everybody, Jerry Dunifer. Right.
Okay, thank you very much, Bob, and good evening, everybody. So, as indicated here, we're going to take a trip down to the South Pole, and I'm going to be concentrating on a couple of the telescopes which are down there. This expedition I took began at the end of 2015, went for the first 9 days in 2016. I went with the company Antarctic Logistics and Expeditions, ALE. And you will see ALE several times when we're down at their base camp. So to get down there, we have to pay approximately 9,000 miles from Detroit. And adding up all the flights, it's approximately 24 hours in the air. So I took 5 flights. The first 3 were commercial, going from Detroit to Miami to the capital, Santiago, capital of Chile, and then Santiago down to Punta Arenas at the southern tip of Chile. The 4th leg of the flight, the Russians took us from Punta Arenas to Union Glacier Base Camp in Antarctica. And then the Canadians took me the rest of the way to the South Pole itself. So I'm going to look at primarily the South Pole Telescope and Ice Cube, which is a neutrino observatory. So spent a day in Miami, and this is the last day of December, and it looks a bit different in Miami last day of December than it does here in Detroit. See a couple guys down there in their t-shirts. So now we're on the third leg, and we're flying south, south from the capital of Chile, going down parallel to the Andes Mountains. I'm sitting on the left side of the plane, so I can simply follow the Andes Mountains as we go along some hundreds of miles. And from time to time, I just took a picture out the window of what was passing by. Here's a nice glacier going out between the mountains. And then finally, we're down there in Punta Arenas. So this is 1,000 people. We're at latitude 56 degrees south, but we're still about 2,600 miles from the South Pole. So we are situated here on the Straits of Magellan, and we're looking south. That's the view. We can see a little bit across the straits. And now we're on the fourth leg. We're flying with the Russians. We are in a four-engine cargo plane designed to carry heavy loads to remote locations with poor runways. So it's a pretty rugged, heavy-duty plane that we are on. Up at the front, there's a screen up here, and the screen allows us to keep track of where we are and what's going on. So this is the view out of one of the front windows with the camera, and this is the view looking at a display of where we are. You can see waypoints on the way down, and currently we are here, and we're headed down to here in Antarctica, flying kind of along the Antarctic Peninsula and going to Union Glacier Base Camp. And we have landed.
That's one flight from when you left there. You didn't stop at the waypoint, did you?
No, we did not stop at the waypoint, so we just kept going. Yeah, one flight from Punta Arenas until we get to the base camp inlet in Antarctica. So this is a plane, big plane, and we're on the blue ice runway, very slippery, and one had to walk carefully to keep from falling down. And here's the proof that I was there. And one more view of the blue ice runway that we landed on. You can't use the brakes when you're landing, reverse thrust, which we did. Fortunately, we had enough. So it's about a 3 or 4 mile drive to our base camp. And here we are. We sleep. There's not an overnight because the sun is up all the time, but we sleep in mountaineering tents, as you see here. So that's mine, and I'm standing outside of my tent. We have 2 people per tent, and my roommate is from the Czech Republic. Fortunately, he spoke a little English because I don't speak any Czech, but a very friendly fellow.
Temperature was there.
Right there is probably, I would say, 15 degrees Fahrenheit. So it's cool, but it's not.
He didn't have any gloves on and stuff. That's why I was wondering.
Well, 15 degrees. But
is Antarctica pretty dry? Would you say?
In general, it's quite dry, yes. But this is not the pole yet. No, this is our base camp. So we're about 80 degrees south latitude. We're about 700 miles from the South Pole. We're about 2,300 feet above sea level. But I think around 15 degrees is the temperature that we had. So this is inside our tent. We actually had cots we could sleep on with mattresses. You see some towels there. They had showers that we could take every second day. And let's see, telephone service. We use the Iridium satellite phone system, and I made a few calls from there. And very good service, very clear. Iridium, but yeah. I don't know. but it's a satellite phone system, and through the satellites, no problem connecting with a few friends here and there. Good, clear communication. That was not all that expensive, surprisingly. We also had a medic that took care of us, and he was located in this building. And there he is, pointing some things out. Very experienced medical doctor. Not only did he take care of people, but from time to time he at the base camp at Mount Everest and would take care of a climber coming down from the summit who were half dead. So he knew how to keep people alive under conditions which might be a bit extreme. Okay, now I'm not advancing here. So I need technical assistance. Okay.
I think you got the mouse over on that screen.
The mouse has to be on that screen.
I think.
Oh. Okay. Okay, thank you very much. So let me go back here a little bit. Okay, so there's our medical doctor that kept us all alive. And this shows a little bit of the base camp that we were in. This restroom, this building served meals. This building over here, we had lectures at least one a day, sometimes 2 or 3 lectures. There were people passing through this base camp all the time who were more than happy to give a talk about their experiences. And then up here is the plane that's going to take us the rest of the way to the South Pole. So this is inside our cafeteria where we ate. We had outstandingly good meals. I was surprised. It's excellent food. Every meal we had while we were there. And because it was just after the New Year, they had a bar that was set up to the New Year 2016. And for exercise, we could go bike riding.
Like
this is for tourists.
research. Oh, really?
Well, anybody, yeah, who signs up to go. It's not cheap. It was pretty. I think it was $60,000, something like that for the trip. And it was 1 week at the base camp and a few extra days, probably about 10, 11 days total.
I would was sitting in Antarctica.
We got light tires. We're going through snow. You got to push hard on the pedals to keep going. So it was a way to get some good exercise. And here's one way of getting around and carrying things on a sled. And here is the plane that is going to take us the rest of the way to the South Pole. So we're at 80 degrees south. That's about 700 miles from the pole. And this is our plane, and these are barrels of aviation. And there's enough aviation fuel there to fill the tanks, which are in the wings. And that's enough fuel to get us to the pole and halfway back. And they don't provide fuel at the pole. So close up of the plane. This is a Douglas DC-3. It has been modified. This particular modification is called a Basler. And this plane was built in 1942 and is therefore 1 year younger than I am. So it was still going. So this is
that like a plane of Theseus? It's just this old that everything's been replaced.
I imagine so. So this is Ken Borak Flight Company out of Calgary, Canada. And it has been chartered to be down there for some few months to fly passengers around.
You said fuel for down and halfway back. Does that mean there's enough already on board to get to the race?
No, there's only enough to get to the South Pole and halfway back.
We got a lot.
Well, we'll get to that.
We're crashing and
Okay. So we were never guaranteed that we could get to the South Pole. It all depends on the weather. And if the weather's bad, they simply can't go. And as soon as the weather is good for a couple days, they're pretty sure of that, then they go. The second day we were there, the weather was good, and they thought it would continue that way. So we went the second day. So here we are getting into the plane. You're looking at the back of the head of my roommate here from the Czech Republic. And now we're on the runway and we're taking off. And we are flying up over the mountain.
Yeah, that plane was on skis, huh?
Oh, yeah, on skis. And the cockpit was open, so I wandered up and talked with the pilot and co-pilot for a little bit. Canadians, very friendly. So this is our pilot. This is the co-pilot over here. And now we have landed. We're about quarter mile or so from the South Pole here. And this is our camping area. And if you can read that, I'm not sure if you can read it down here. This is the world's southernmost resort. And here, so we got a couple tents there for meals, things like that, and then more mountaineering tents for us to sleep in. So the doctor has come with us to keep us all alive. And they've just been celebrating the New Year, so you see the balloons. This is the interior of our tent. Not as fancy as the previous one. We have to just sleep right on the floor. And there's barely enough room for two sleeping bags side by side, but we fit. Okay, now looking from our camp towards the South Pole, you can see our plane here, which is about halfway to the National Science Foundation Research Center, which is up here very close to the South Pole. So walking towards the research base, you see a ceremonial pole. This is not the actual South Pole, ceremonial pole. And there are the flags of 12 countries around it. These were the original 12 countries that signed the treaty, setting aside this continent for research purposes only, not to be exploited in other ways. So here I am by the ceremonial pole, close up. Now it's quite a bit colder here because we're at the pole and we're at 9,300 feet above sea level. So it's very cold. It's about minus 30 degrees Fahrenheit. So I'm dressed up there pretty warm with my goggles, everything else.
Does the location of the poles ever shift because of ice?
There is ice there. The ice is moving relative to the axis of rotation. And it shifts about 10 meters, per year, which is about 1 inch per day. So the ice is actually sliding slowly over the bedrock, fairly slowly.
How thick is the ice over there, you know?
I do. Now I'll show you in a second.
Okay.
Does the actual image change due to magnetic field or shift and axis not
the pole itself can change relative to the solid Earth. So the rotation axis can actually move around a bit. And in addition to that, the ice is also moving over the bedrock, which is below it.
So at one point when they put the ceremonial pole there, was it sort of close to?
Yeah, it probably was at one time.
Okay.
Yes. And then things have moved.
Quicker thing change.
So here we are. There I am again, showing you I was there. And here's the South Pole right here. That's it. And that was put there on the first of the year. Lined up the rotation at that time. Altitude there is 9,300 feet above sea level. So we're pretty high. The air is quite thick, not only because we are high, but because the Earth is rotating. This rotational motion acts like a centrifuge that tends to pull the air away from the poles and down towards the equator. And because of the Earth rotation, you encounter a lower air pressure there that you might find elsewhere at an altitude of maybe 11 or 12,000 feet. So you can really notice the altitude. Air is quite thick.
Do you have supplemental oxygen?
No, we don't need it yet.
Well, I do know somebody. Yes.
I they can probably people something like that. Now the group I flew down with, there were probably only 30 on the plane, and not everybody, in fact, was going to the South Pole at that time. There's a nearby mountain, Mount Vincent, which is the highest mountain on the continent. Few people were going to climb that.
So anyway, you can see Amundsen, the first person to get to the South Pole is a group of Norwegians. And you got there on December 1911. And then later, Robert Scott, another group of people got there. Amundsen was something like, so we arrived at the geographic South Pole. And when Robert Scott got there, he said, oh, yes, but under very different circumstances than those expected. They were expecting to be first.
And when they got there, lo and behold, somebody had beat them to it. Now, the Norwegians got back safely with no problems. Unfortunately, everybody in the British team died before they got back. They had some bad weather, which slowed them down. They ran out of food. None of them survived. Okay, this just shows you the fixture on top of the pole. Oh, let me just back up a bit. So when this picture was taken, because of the drift of the ice, the South Pole itself really is not here, but it's about 4 inches to the left of the pole. Yeah, they reposition it for the first of the year. Okay, so and each year for the new pole, they put a different type of ornamental object on top, and this is what they did for the year 2016. Okay, we're going to go.
They have like a display.
Yeah. Inside the research base, they have a display case with all the ones from previous years. Okay, so we're going to get a tour. In the base, they're on New Zealand time, and we are on Chile time. So when we got our tour, almost everybody was sleeping. There weren't too many people to see except the tour guide that we had. I was just looking in one of the labs. They grow a little bit of food hydroponically without soil, just water and various nutrients, and some vegetables, some fruit. So this is part of their garden. They have recreational facilities like this ball court, place to exercise, pool table, and another place to relax in. Okay, now we're up on the second level. We've gone out on the balcony and we're looking out towards the telescopes. So there's a set of radial telescopes here, and the neutrino observatory is centered here. So looking at the radial telescopes and zooming in a bit, looks like that. Zooming in a bit more, we see this. For this talk, I'm not going to talk about these two telescopes, radio telescope. I'm going to concentrate on this, the South Pole telescope. No, I don't think it's under construction. It's just that's what they build up around it to probably protect it from wind and things like that. But I believe it's been there for quite some time when this picture was taken. And this is the top lab for the neutrino observatory, seen a bit closer. Yes, that's part of the ice cube. Neutrinos
under the ice.
Yeah, most of it's under the ice, right? So that's the surface. That's a small part of it.
Are there at the facility and stuff?
Most of it's in the large research building. And
One big building?
mostly, yeah, it's not entirely, but mostly in that one building.
Click next, it'll go away. There you go.
Okay, so that's part one. Here we're going to do part two. So I'm going to look a little bit at the research station named after Amundsen and Scott, the first people to reach the South Pole. I'll talk a bit about the South Pole telescope and ice cube. So this is the map of the continent. So let's see, this is the South Pole here. And let's get around a little bit. So our base cap is at about 80 degrees south latitude. So 80 degrees south latitude is this line. So this is the base camp was right there. Just a short distance away is Mount Vincent, the tallest mountain on the continent. And at one time, I was going to fly there. They were looking for people who would pay to fly the plane there to see it. And I volunteered to do that. And we had another person that there were two of us, and we decided that we would share the costs. I think it's maybe $8,000 or something. But then he backed out. So I foolishly decided I would not spend $8,000 for the trip to see the mountain and land at the base. I wish I had now. But, so anyway, that's where our base camp was located. This is the South Pole and the research station. The U.S. has three different research bases, one at the South Pole, one down here, and then there's one at Palmer Island up here. So I've been to Palmer Island and I've been to the South Pole. South Pole by plane, Palmer by boat. These other red markers of various research in various countries.
Jerry,
Yes.
when you point with your laser pointer, the Zoom audience cannot see it, but if you use the mouse, we could, I think.
You can see it?
Yeah, that's better. Yes.
Okay, I'm with you. Right. Okay, so anyway, this is the South Pole. McMurdo Station is down here. And Palmer Island is up here near the tip of the peninsula. So at this angle, it's hard for me to see. So Palmer Island is about there. So various countries have research bases scattered around. For example, there is, I can see it here better, there's Vostok, which is a Russian base, which is right there. Can you see the mouse, the pointer? That's Russian. The Japanese, this is Dome Fuji. This is one of the coldest places on Earth. It's about 12,500 feet above sea level and has a record cold measured there. Okay, so this is the main research base as seen from the side. It is on pilings to keep it above the snow. And furthermore, there are hydraulic jacks connected to the pilings. So as the snow accumulates underneath, they can jack the building up and they can jack it high enough to get the first floor up to where the second floor is. So I'm not sure how much they've had to do that. They had not when I was there, but perhaps they have since. So a little bit about the research base, Amundsen Scott South Pole Station. The construction began back in 1956 as part of the International Geophysical Year. It has been occupied since that time, operated by the United States Antarctic Program and funded by the National Science Foundation. As I showed earlier on the sign, the altitude there is 9,301 feet. And the ice, in answer to a question, the thickness of the ice there 8,900 feet. And again, it's drifting about 10 meters per year. Temperature ranges at the South Pole from about minus 117 Fahrenheit to plus 10 degrees Fahrenheit.
Minus 117.
When I was there, it was about minus 30, and we had at least 10 or 15 miles an hour wind, so the wind chill factor probably 40 or 50 below zero. It was very cold. That's why I had my goggles on when I was outside. They get 60 to 80 millimeters of snow per year. It's only 2 or 3 inches, so it's not a great deal. During the summer, they have up to 200 scientists and engineers that work there. In the wintertime, they cut the crew down to about 50 that stay over the winter. So the structure you saw has 2 floors, 80,000 square feet. It was constructed between 1999 and 2008 at $150 million cost. And a little bit more about the South Pole Station. The electrical power they have there is generated by 3 generators burning jet fuel. They can communicate with the rest of the world. They have 3 NASA tracking and data relay satellites, 1 Department of Defense satellite, and also the commercial Iridium satellite constellation, like I use at the base camp. And again, they got a small greenhouse for vegetables, fruit, and herbs. They are on New Zealand time. The runway there, which we landed on, 12,000 feet in length. And during October through February, they have several flights per day. The ski equipped, and these are LC-130 Hercules, which fly in from McMurdo Base. There's also a snow road from McMurdo to the South Pole. And they do a variety of research, quite a bit of astronomy and astrophysics, but also some atmospheric studies, glaciology, geophysics, meteorology, and biomedical studies.
That snow road, that's like, what did it look like, isn't it? How far is it?
Well, that's got to be over 1,000 miles, I'm sure. Maybe 1,500. That's just a guess, but in that ballpark.
Do they keep that maintained year round?
I would think they'd only use it in the summertime. In the winter, it gets very, very cold, very dark. I don't think there's anybody moving around outside, so I don't think anything happens for several months during the winter.
Do they have issues with velocities and stuff? There's a huge elevation change between McMurdo getting up.
Yeah, McMurdo sea level, and they're going up to 9,000 feet.
Yeah.
I don't know the answer to that. It's certainly possible.
I didn't know there was a road.
Yeah. Yeah, there is a road. So anyway, this is the Hercules. This is the plane that does quite a bit of flights back and forth between McMurdo and the South Pole on skis. You see a mountain in the background. So this is not at the South Pole because it's very flat at the South Pole. This is at McMurdo, and this mountain is Mount Erebus, the second highest active volcano on the continent. About 12,400 feet at the summit above sea level. Oops.
I honestly did not know there were active volcanoes.
There are, yeah. There are several. Okay, a bit about the South Pole telescope. The telescope operates at microwave, millimeter, and sub-millimeter range. It has a diameter of 10 meters or 33 feet. It was built 2006 to 7, $19 million cost. And it is something like $16 million per year operational cost. It has a fairly large field of view, about 1 square degree. And the surface of the main mirror is smooth to 1,000th of an inch. And the secondary mirror is cold and cooled down to 10 kelvins, 10 degrees above absolute zero. And it has been for several years used in the study of the cosmic microwave background. So why at the South Pole? Turns out it is the best observing site in the world for millimeter waves. Because of the high altitude and low temperatures, there's very little water vapor in the air. Water vapor tends to absorb millimeter waves. The atmosphere is very stable there because the sun does not rise and set daily. And in fact, there's no electromagnetic interference from the sun during the 6 weeks of polar night. So just another view of the South Pole Telescope. This is the dish, and the receiving cabin is here, and control facilities are down here.
Does it work better during the polar winter?
Certainly the air would tend to be a little drier. I don't have any.
You're running year round.
Yeah. Year round. It might be a little better. Yeah, that would be my guess, but I don't have any statistics on that. So another view of the telescope there, the South Pole Telescope. Okay, a little bit about the neutrino observatory. So this is a giant detector at the South Pole, occupies 1 cubic kilometer of volume, and it starts 1.5 kilometers, that is about a mile below the surface of the ice. It was constructed over 7 years, completed in 2011, and it cost $279 million. So it was very expensive. While they were working, the work was carried on November through February, the Antarctic summer. They worked 24 hours a day, 7 days a week. And it has been looking for point sources of cosmic neutrinos coming in with very high energy. These would be neutrinos which have energy measured in the electron volts. That's the energy gained by an electron accelerated through a voltage of 1 volt. So they're looking for energies of 10 to the 11th power. That's 100 billion electron volts, up to 10 to the 21 electron volts of energy. So it's a billion trillion EV. Looking for the highest energy astrophysical processes. And then for comparison, the Large Hadron Collider in Switzerland can accelerate protons up to about 7 times 10 to the 12th EV, electron volts. And the highest energy neutrino at the time I was there that they had detected was 8 times 10 to the 15th EV. That's about 1,000 times more than the Large Hadron Collider in Switzerland does. And as I mentioned, the lead institution is the University of Wisconsin at Madison. Okay, so this is a view of the surface facility. And before I went, I had talked to one of the primary people overseeing the program at the University of Wisconsin, and had made arrangement for one of his postdocs down there on site to take me a tour of this building. But unfortunately, somehow the NSF, the National Science Foundation, found out what we were planning, and they said, no, you can't do that. So I didn't get to get a tour inside that. There's not that much to see. Okay, here is what it looks like, and it's quite impressive. So this is the surface that you see. The active detectors are down here, starting about a mile below the top of the ice. So they've drilled a number of holes, a total of 86 holes. It's going almost down to bedrock. And then they have strings of detectors. So here's a particular string going down. The detectors are called DOMs, D-O-M, digital optical module. And 160 of them, which are below the ice. And so they come down in strings. They have 60 DOMs per string. And this is where they're all situated. And they send the data that they receive about passing neutrinos back up to the surface. And from there, it's sent by satellite to the University of Wisconsin.
Perfect. How you doing? Mr. Narcissic, how you doing?
Okay.
Oh, I'm all comfy over here.
All right.
Okay. Okay, another view of the lab at the surface. And then what are neutrinos? Well, I won't go into too much detail. They are practically massless particles. They're generated by in nuclear reactions. They travel very close to the speed of light. They're extremely penetrating. They can go easily right through the solid Earth. And so this is the detector to detect those coming from all over the universe. North, south, east, west, any direction, even those that pass completely through the Earth to get there. So as indicated, these are generated by some of the most violent and least understood events in the universe. Events like supernova explosions, active galactic nuclei, black holes, and things like that. And then of interest is, other than particles of light called photons, neutrinos are the most common particle in the universe. So here's a nice view of the surface facility taken at night. There are the southern lights. We were there during the day, so we didn't get this view. The sun simply went round and round in the sky, never set for us.
Was that a comet or a meteor top there?
Say again?
Comet or meteor?
That looks like a comet. I don't know. That's right. I would guess it's a comet, but no, so it's definitely not a neutrino.
Hey, Jerry,
Yes.
audience is asking you to talk to the computer.
So
People online.
I'm sorry. My apologies to the people online. I'm not talking directly at the computer as much as I should. So there's a brief description here of how the neutrino detector works. I don't know if I want to go into too much detail. The high energy neutrinos interacting with ice molecules generate high energy electrons, muons, and tau particles, which are traveling through the ice at more than the speed of light through ice. And this generates something called Cherenkov radiation. And these DOMs are looking for the Cherenkov radiation. So the signals are digitized, they're sent by cable to the ice cube lab at the surface. And from there, they're sent on to the University of Wisconsin by satellite. And here's a time exposure. And at the bottom is what a typical signal would look like generated by a neutrino. Another, and from the color and the orientation of the signals and the size of the signals, one gets the energy of the neutrino, the direction in which it's going, and so forth.
That's great. It's more concentrated at the poles.
The neutrinos, no.
No, so like we're getting the same amount here, you want to, okay, they're not. Okay.
The reason the detector is there because they got this cubic kilometer of ice, very transparent ice. And because of that, they built this unique detector, most by far most sensitive neutrino detector in the world. So if you go inside that surface structure, you see tons and tons of cables like these. And here's a view of somebody working in the dark. A little bit about the construction of the neutrino detector. The holes for the string of DOMs is drilled using high pressure water. Takes about 48 hours to drill each hole, 2.5 kilometers deep. While they're drilling, they can go up to 2 meters per minute. About 200,000 gallons of water is melted per hole during the drilling. They use about 4,800 gallons of fuel to drill each hole. And the average time, once the hole has been drilled, to deploy the cable with its 60 DOMs is about 11 hours. And the critical thing is they must do it quickly before the water refreezes.
Hey, Jerry.
Yes.
That's the goal on starting with the neutrino. Is it just to find out where the hot spots are in the sky?
They would like to find out where the hot spots are, where they're coming from, and information about them. How much energy do they carry? What can they tell us about the source?
And they're doing it.
Well, yes, they are. Yeah, I'll get into that here in just a couple minutes. So this is the view.
Outside has a live meeting going yet?
This is the view of one of the drilling sites. And then finally, they get to the last dom. And so they're autographing it. Here it is, last dom. And it's ready to go down. Okay, and so down it goes, going down just about a mile below the surface. Now, for some reason, I'm having trouble again.
Hit next.
Hit next.
Yeah.
Which is,
And that menu pop up.
okay, anyway, so that's the last view. Down it goes, down this hole, which is 2.5 kilometers deep. This is a view, an artist's view, of what it looks like down in the ice. And so this was a report from the time I was down there, and at that time, it had been in operation somewhat over 4 years, and they detected 54 events, what they called astrophysical neutrinos. These are very energetic neutrinos coming from outside the solar system. So after 4 years, 54 unique events. They had not identified any significant point sources at that time. They detect about 100,000 atmospheric neutrinos, which are generated when cosmic rays interact with our atmosphere. They detect about 100 billion cosmic rays per year. And I need not go into these other things. So now, since my visit, which was 8 years ago, we have additional information. The South Pole Telescope has been added to the Event Horizon Telescope, which is used to photograph supermassive black holes, in particular two so far, one in galaxy M87 and one which is Sagittarius A star at the center of the Milky Way galaxy.
Is that a visual telescope or radio?
No, this is using millimeter waves.
Okay.
The South Pole Telescope, again, is in the radio range, millimeter, and sub-millimeter range.
Are there any visual telescopes? Or
Nothing significant, no. There may be a few small ones, but it's primarily the neutrino, the neutrino observatory and the radio or millimeter wave observatories. Okay, ice cube neutrino detector. It has detected 3 types of neutrinos and has now detected neutrino beams coming from various point sources outside the Milky Way. And they now have begun upgrades. So there's an ice cube upgrade currently underway, be followed by ice cube generation 2. So first of all, the Event Horizon Telescope has been used to look at 2 black holes, supermassive black holes at the centers of galaxies. And this just shows you where the initial ones were located. And notice there is one down at the South Pole. There's a couple at the Atacama Desert in Chile, a couple on Mauna Kea in Hawaii, one in Arizona on Mount Graham, one in Spain. There's one now in Greenland, more recent one. So this is now the South Pole Telescope is a member of that collaboration. And I show you just a couple more, sub-millimeter array on Mauna Kea and a large millimeter telescope at Sierra Negra, Mexico. So these are just 3 examples of the telescopes that are used to get pictures of the supermassive black holes. So let's start with M87. That's an elliptical galaxy at a distance of 55 million light years. And this is M87 star, which represents the black hole. This is the first photo which was released in April 2019. The data was taken 2 years prior, but it took 2 years intensive work before they could They get the data to a point that they can generate a picture. So what you're looking at is radiation coming from the plasma, the ionized material circulating around the black hole. The dark area in the center sometimes is described as the shadow of the black hole, something like twice the diameter of the black hole itself. And this is a picture, well, several pictures of that galaxy. First one's taken by the Hubble Space Telescope. If you look at the line here, this represents 3,800 light years. And this is a picture. And zooming in towards the center, this is from ALMA at 230 gigahertz. So this is millimeter wave, showing a jet which is being ejected from the center. And then the very large baseline array in the US, looking very close to the center. And then finally, the Event Horizon Telescope itself, showing you the location of the black hole at the center. This shows you the change in M87 star in 1 year's time. So April 2017 was the first picture released. I'm sorry, this is the first picture that was taken. And April of 2018 is the second picture taken a year later. So it looks basically the same, but what they noticed was that the brighter area had rotated about 30 degrees counterclockwise in that time. And then more recently, they released pictures taken with looking at polarized millimeter waves. And you can see a streaky pattern here, which represents the location of magnetic fields. So they're very strong magnetic fields concentrated in the vicinity of this black hole. In the center of our own Milky Way galaxy is Sagittarius A star. It's very much closer, 27,000 light years away. This picture was released 3 years after the release of the M87 photo because it was much more difficult to process. Much smaller in size, things are happening more rapidly, and it took much more work to finally generate this photo. So comparing M87 with Sagittarius A star, they look about the same. They occupy, or they subtend pretty much the same angle. That's what they look like. They're very small. The angle subtended is approximately the angle that would be subtended by an orange sitting on the surface of the moon as viewed from the Earth. That's how small an angle they're looking at. Comparing the sizes of the two supermassive black holes, M87 is by far the largest, and the black hole has a mass of something like 6.5 billion times the mass of our sun. Therefore, it has a diameter, which is by far the largest, and they're comparing it here with the solar system. So here is our solar system orbit of Pluto, and Voyager 1, which was launched, 67 years ago or so, is this far out from our solar system, all compared to the size of the M87 black hole. Sagittarius A star looks like this, and it just fits inside the orbit of Mercury. This supermassive black hole has a mass of about 4 million times the mass of the sun. So 4 million solar masses, 6.5 billion solar masses. And then released just a few days, about 3 weeks ago, they show on a Sagittarius A star, center of our Milky Way galaxy, in polarized radio waves. So you can see the presence of magnetic field, which is there. Okay, let me look at the last part quickly here. Some of the future activities that they're going to be doing with the Event Horizon Telescope. They've already taken data in 2021, 2022. They're currently taking data this month. that has yet to be sufficiently processed to release pictures. They have added already 2 additional telescopes. They're going to higher frequencies. Previously, it was 230 gigahertz. Now it's 345 gigahertz, a little bit less than 1 millimeter wavelength, giving an improvement of 30% in resolution. They're going to have the next generation Event Horizon Telescope, NGEHT, which will add 8 more telescopes for a total of 20. And that will increase the dynamic range, the range of intensities they can see, by a factor of 100. That will be followed by Black Hole Explorer, BHHEX, which will connect these telescopes to an Earth orbiting satellite, which will increase the resolution by another factor of 5. So over the next several years, we should expect to see more and interesting things in regard to these black holes. Okay, a little bit about neutrino detector. Already talked a bit about how it works. Now looking over a decade of time, they've seen high energy neutrinos, 10% coming from the Milky Way and 90% are extragalactic, outside the Milky Way. They detected 3 types of neutrinos, electron, muon, and tau neutrinos. And analyzing a decade of data, they got 670,000 muon neutrinos detected. And they detected 80 events which have tera or trillion electron volt energy coming from within 0.2 of 1 degree of M77. That's another galaxy, also known as NGC 1068. And they've also detected other point sources, 2 other galaxies, PKS and TXS, at distances of billions of light years away. M77 is 45 million light years away. And just to show you where M77 is, this is the southern part of the sky in the winter. And you see the constellation of Orion, Betelgeuse and Rigel, Sirius, Taurus, the Bull, and here's Cetus, sea monster, and M77 is right there. In M77, the galaxy looks like this. Central region looks like this. It's enclosed in dust, can't see in to see exactly what's going on. We can measure the neutrinos that are coming out. And now there is a real-time follow-up program which targets transient sources of high energy and clusters of low energy events. And once they're detected by IceCube, it sends the arrival direction in less than 1 minute to optical, X-ray, and gamma ray observatories, so they can take a quick look and see maybe what the source is. So there are enhancements coming to IceCube. IceCube Upgrade is a 3-year project, which is adding 7 more strings of DOMs for a total of 700 more, for the purpose of looking at lower energy neutrinos. And then over an 8-year time period, there will be IceCube Generation 2, $350 million project. You'll add 180 more strings of DOMs, increase the volume there under the ice by a factor of 8. And when finished, there will be 9,600 DOMs. Overall sensitivity is going up by a factor of 5. They expect to detect 1 million neutrinos per year of high energy. And just show you here, the central region in red is the current IceCube observatory. In green is what they're going to be enhancing over the next 3 years. And then in blue, they're showing you Generation 2, which will increase the volume by a factor of 8. So that's will be happening over the next decade or so. So it's this top view looking at IceCube. Second from the left, on the right one, you see additional spots in red. That's where the new strings will be going in. And the 2 on the left show you what they're going to be doing on the surface to measure cosmic rays coming in. Okay, to finish up, let me tell you what happened on the way back. So after our tour and having been there for about 24 hours, we only had enough fuel to get halfway back. Fortunately, this had been planned out in advance, and so they left a cache of barrels filled with aviation fuel. So we stopped for about an hour and a half and by hand pumped the fuel from these barrels up into the wing tanks. We had enough fuel to get back. And then we loaded the empty barrels into the back of the plane. And then we continued our flight back to the base camp.
Was that a base or just a?
The fuel that we're just looking at the barrels, no, it's halfway back to base camp because we don't have enough fuel to get all the way back. So we have,
It wasn't a different base.
no, it's just a cache where they've been. Well, I don't know. I wasn't up in the cockpit. I don't know how they found the location, but well, they got GPS. They got GPS, so I think they don't have any problem finding the location. But anyway, this is flying back. Oops, wrong direction. And now we're almost back, and there's a little hazy path. That's our base camp, and that's where we're headed. Okay, so those of you out in TV land, this is where we're going. So now we're back on the ice again. We've landed. And then here we are getting off the plane. And here's a close-up of the skis that we've been on. So my hour is up. I could take another 3 or 4 minutes if you want to see a few pretty pictures.
Yeah.
Okay. After we got back, they took us on 3 short trips, a few miles from the base camp to see things and to do a little hiking. I'll show you 2 of them. So here we are. These are the vehicles they drove us around in. So first of all, we went to do a little climbing. And the ice, pure ice is blue in color. So this was one of our guides. She was very friendly. I forget her name, unfortunately. She was Peruvian. She's a mountain climber. She's climbed the highest mountain in South America, which is 22,800 feet, I think. So she was one of our guides. We went to what she was calling the elephant. So with a little imagination, here's the face of an elephant. Here's the eye of the elephant. Here you can see his big floppy ear here. And here's a bit of his trunk. So we're going to climb up here past the elephant, climb over the saddle and look on the other side to see what's there. I'm still here. Here's some of that very blue ice. And here's our guide leading me on. She's saying, hurry up, what's taking you so long? And here you can see a few people going up to the saddle. And we look over the saddle to the other side, and what do we see? More ice and snow. And now we're on the way back, and here are our vehicles, 2 vehicles down below, you can see here. So we've climbed probably a few hundred feet, maybe 1,000 feet up. So going back to the vehicles, see some interesting patterns in the rock. And this one gal got so excited, she literally jumped 8 feet up into the air. You can see that. That's really excited. But interesting wavy patterns here. I don't know if it's sedimentary. I don't know if it's put down by volcanic layers. I'm not sure.
Yeah, my wife would be able to tell you. Get that reading.
Oh, good. Well, then we need her. I'm not, yeah. Okay, and then the last adventure I'll show you took us out to try out crampons. So these go in our boots. They have steel spikes, and they're very good for walking on ice without slipping. I was amazed how good they are. So we're here to good area to try them out. It's very slippery ice, so we're able to hike around on it. Also, a very windy day. You can see the snow being blown around by the wind. No wildlife. No. That's my last photo. What I found is it's a beautiful place. The color green is totally absent. Nothing is green. There are no animals. There are no birds flying in the sky, not a one. And if you want to live there, you got to bring everything you need with you because you won't find it there. Okay, that
All right.
finishes up.
Thank you, Jerry. Righty. Anybody have any questions?
Yeah.
Hands are up. Go ahead.
That I should have asked you. There was an Irish explorer by the name of Ernest Shackleton. Wow. He would where he got stranded. Was
Yeah, his boat got stranded when he was. Yeah, he was his boat was in the ice for what, 2 years or something.
he did not use one crew man.
That's right. Yeah, no, he saved them all.
Yep.
Yeah, they never got to the continent. They were still out in the ice and they got frozen in. They were stuck in the ice for a couple of years. Yeah, yes.
Can you repeat the question, please?
Yeah, the question was about Ernest Shackleton and where he was relative to the map I was showing of the continent. So yeah, he was trying to get to the land with his crew and never got there. He got frozen in place and spent, I think, a couple years or so. The ice eventually destroyed the boat. So they were marooned on the land living on seals, I think, barely for months and months. But the remains of their boat, they were able to put together a smaller boat, which he and I think 2 or 3 other men sailed one of the lifeboats.
Find his way back.
Yeah. We're able to sail to one of the other island people. And eventually he landed on the wrong side of the island. We had to climb up over a mountain to get to the side of the island where people were. South Georgia. I'm not sure. It could be. Anyway, yes. Yes.
You said that the ice, something, some of the volcanoes travels faster than the speed of light. I don't think anything could travel faster.
I didn't make that clear. The neutrinos interact with the ice molecules, generating things like electrons, which are traveling faster than the speed of light. Not in a vacuum. Light traveling through ice. You have to divide by the index of refraction, which is like what, 1.3 or something typically. So the speed of light in ice is like 70% of the speed of light in a vacuum. And these very energetic particles are traveling very close to the speed of light in a vacuum. So they're going faster than the speed of light in ice. And that generates a type of radiation called Cherenkov radiation. And that's what these DOM, what these detectors are detecting. Cherenkov radiation, because the charged particles are going faster than the speed of light. Anything else?
Ice blue, or is it just reflected to the sky?
Ice is, yeah. Pure water ice is blue in color. So, when you have it in large quantities, you can easily see the blue.
Lake Superior look exactly the same.
Yeah.
It seems with the the first condition to the sensors and the ice cube would be a lot of maintenance. How would they do?
You don't.
I think once the detector in place, there's no maintenance, they can do it down there. And I think I heard somewhere that they maybe lost a few of these, I mean, I don't think very many. So the ice is drifting, as I said, about 10 meters per year at the surface. Down at the bedrock, I think that ice is locked in place, mostly. And so what they, yeah, probably something like that. But they did they drilled some exploratory holes and found out they didn't get too close to the bedrock. The ice pretty much was moving as a solid unit, only down close to the bedrock where it's dragging. That I think it tends to get left behind. That would mess things up. So the DOMs don't quite go down quite that far.
All right. Well, thank you, Jerry. Okay. Okay, so our next Star Party and open house is at Stargate Observatory, Saturday, April 27th. Board members, our next board meeting is Monday, the 29th. Our next general meeting is on May 6th at Cranbrook. So some of us meet afterwards at the National Coney Island at Groesbeck on 12 Mile here. Officers, if get your reminder to get your end of the month report to Dale, and so that's it. Clear skies, everyone. Good night. Thank you for attending. See you, everyone.
Yeah. We got something for you though, Bob, if you wanted to see it. Hello, Bob.
I'll stay online here while I clean up. What's up?
Bob, the